Of the basics, then we'll move to the complex, inshallah. So today we are going to try as much as we can to cover basic electricity, do Ohm's law, solve questions on Ohm's law, and I'm majorly on resistance in series, and if we still have time, we're going to do resistance in parallel. Please indicate if you can hear me properly or if I have to increase the pitch of my voice. All right, I'm going to be sharing our slides with you now, and we're going to start. But before the slide, we have all heard about electricity at one point or the other in our course of junior secondary school, even in primary school. We've heard about electricity and we've done some basic electricity. So, anybody, what do you understand by electricity? What have you heard about electricity? Electricity, anybody? I am waiting for our chats. So anybody, if you've heard about electricity, what is electricity? Or do you have an idea what electricity is? Electricity, guys. Electricity. Okay. Flow of current. What else? We have different kinds of electricity. We just don't have one. We have static electricity. We have current electricity. It means if electricity can be static, it means current does not flow. Something else. Electricity. Okay, everybody is saying is the flow of current through a conductor, and that is more like current electricity. Okay, let us accept it that way. But generally, electricity means electricity we cannot say there is electricity without current. So, or we cannot say there is electricity without charges. Then the charges can be static. In the case of static electricity, I know we can all recall a time when we were learning how to create current or how to create charges. And our teachers taught us to rub our pen on our hair and use it to attract a sheet of paper, like a tiny sheet of paper. When we're told that when you rub two stones together, you can get tiny electrical sparks, like tiny electric sparks. Those are static, those are just generation of electrical charges. And we cannot have electricity without electric charges. So we learned basic electricity. I'm sure that an appreciable number of us would know what electrical charges are. So today we're going to be doing current electricity. And in the current electricity, we're going to, anybody, example of things that are achievable with electricity. Things that we can get when we have electricity. An example is our radio. Without electricity, our radio would not work. So an example of the things we can get with electricity is our radio. Another example, guys. Another example or other examples. Other examples. Light bulbs, other examples. Okay. So let us, without wasting our time, though, I'm sure that we're a little bit warmed up. So okay, guys, I hope you can see my screen clearly. We're doing physics and it's still electricity. We're going to be starting with basic definitions in electricity. Current. I'm sure we've all heard of current before. Because when I said all of you should define electricity, you said when current flows, when current flows, when current flows. What is current? Current is the motion of charges from one region to another in an electric circuit. Current is, I just said, I just spoke about charges a few minutes ago. So current is the motion of those charges. When those charges are moving, then we can say there's electric current in this. For example, when PHCN, NEPA, when the power supply is interrupted, it means that the flow of charges has been stopped. So current means motion of charges from one region to another. For example, when you put your battery in your remote, I'm sure that at one point or the other, we have all broken remotes. If we did not break remote, somebody in your house has broken a remote. Then you have seen that behind the remote, there are tiny wires, there are small wires, there's a board, all of those things. They can only work when charges flow through those wires. If charges don't flow through the wire, the remote would not work. The sensor would not work. It cannot change channel, not do anything. So because we want our remotes to work, we're going to get batteries. Batteries have stored charges in them. So when we put those batteries in the remote, those stored charges, they begin to pass charges. They transfer charges to those tiny wires, and on the chip, the buttons start working, the remote start working. So current is the motion of charges from one region to another in an electric circuit. In a basic electric circuit, I'm sure we have all seen. Oops. Mute yourself. Okay, sorry for the interruption. Somebody was not muted. Okay, as I was saying, sorry, please, if you don't understand what I'm explaining, kindly let me know. Okay, all right. As I was saying, sorry, current means the flow of charges from one point to another. I want to show you a simple sample of an electric current. I mean, electric circuit. Okay, guys, I want to show you This is a sample of a simple electric circuit. I hope you can all see it. Please indicate by waving your hand if you can see this. This is a sample of a simple electric circuit. This is the battery. The battery is what gives out the current, the charges. Then there's a resistor, there's a voltmeter. We have not explained those. But this is a sample of a simple electric circuit. Okay. Then current can also be defined as the rate of flow of charge around the circuit. For example, charges are mentioned in coulombs. I'm sure we learned that when we're learning static electricity. So the rate of flow of charges in an electric circuit is also the current. So if you are given a typical OBJ question in WAEC, and if you are given a typical OBJ question in WAEC, and you are asked that the rate of flow of charge in a circuit is what? Is the current. Because we should not always expect that questions will come directly. Then the quantity of charge is measured in coulombs. So it is Q over T. Current can also be calculated as Q over T, quantity of charge over time. I have a simple question here for you guys. So please listen attentively, guys. In 30 seconds, I want you guys to answer this question. The current of 4.5 amps. I have decided that I'm not going to be typing most of my questions again. I'm going to dictate them to ensure that you guys are following. So please listen attentively. A current of 4.5 amperes flows through an headlight that we don't know the quantity of charge in 1 hour. Calculate the charge quantity. A current of 4.5 amperes flows through a car headlight. How many coulombs of charge flow through it in 1 hour? We should know that time in physics is measured in seconds. Time in physics is measured in seconds. So let's okay, guys, I'm expecting our answers. Our 60 seconds is over. No answers yet. Current. The current is 4.5 amperes. Where are we making the mistakes exactly? Where are we making the mistakes exactly? I don't know. Okay, let's see. Okay, I hope you can all see the whiteboard. I said current I. Current I is equal to coulomb over time. In the question, we're giving current I to be 4.5 amperes. Our given time to be 1 hour. I'm sure that we all know that in physics, time is measured in seconds. So our time is, we want to convert it to seconds. 2 minutes first, we multiply by 60. So we have 60 minutes. From minutes, we'll convert to seconds. So we have 60 times 60. That's our 60 times 60 is 3,600 seconds. So if we have our time to be 3,600 seconds, our current to be 4.5 amperes, then what is our Coulomb charge? Making Q the subject of formula, we have current times time. So 4.5 times 3,600. I hope you all understand what I'm explaining. So 4.5 times 3,600 is what, guys? I await your answers. Okay. So give me your answer in standard form. Okay. Nice one, guys. Your answer in standard form. If you said the answer is 16,200 coulombs, can I have your answer in standard form? It is best that you leave physics answer in standard form. Yes, nice one. Thank you, guys. Thanks. 10 raised to power 4. 62 times 10 raised to power 4. When you leave your answer in standard form, those zeros can just be left alone. 1.62 times 10 raised to power 4. Nice one. Nice one. Okay, thumbs up to you guys. You have all done well. Okay, the basic current question. I'm going to give you more questions on that, but let us move on to the next thing. Okay. So after currents, another thing is, wow. This is supposed to be, this is not electromagnetic force. I'm sure I made this mistake when I was preparing on the slide. This is supposed to be electric field. Okay, EMF is supposed to be electromagnetic force. No. Potential difference, basically. We're talking about voltage, potential difference. Potential difference. Potential difference is also known as voltage. And it is defined as the work done on 1 joule when a coulomb of electricity moves from one point to another. Potential difference is measured in volts. When an electric current, the work done in moving, just like when we're defining work done is defined by distance. You cannot define work done without distance. So here we're saying that potential difference is also known as voltage, and it is defined as the work done on 1 joule. 1 joule. What do we measure in joules? Work done. When a coulomb of electricity moves from one point to another, the potential difference is now measured in volts. Like we have all heard of voltage, and we know there are instruments that are used in measuring voltage. Then aside from voltage, we are going to be learning resistance. Resistance is the opposition of flow of current in a circuit. Any component that performs this is a resistor. So a resistor is a component that opposes flow in a circuit. For example, basic circuits that we know. If you arrange your voltmeter, if you arrange resistors, batteries, or anything that can produce current, and there's a voltmeter, or want an advanced arrangement. In that advanced arrangement, we have maybe an inductor, we have switch, open and close switch, and we have series of resistors, like several resistors, like they might be arranged in series and parallel. I'm sure that we're going to learn that later on in the course of this class. They can be arranged in, resistors can be arranged in both series and parallel. Then the series arrangement will be parallel to another series arrangement. Then that's like an advanced, for secondary school level, that's like an advanced arrangement. So all of that in that arrangement, everything in that arrangement works in such a way that they move with the flow of electricity. They want electricity to flow. The switch wants it to, when it is open or when it is closed, it wants it to either flow, or it wants it to stop, or it wants to stop the flow. But the resistor opposes the flow of electric current. It means if the current is moving in the positive direction, the resistor wants to move in the negative direction. I hope you all understand. These are instruments and their parameters. For this resistance, I'm sorry, it's ohm meter. That was a typographical error on my part. So we have current. Current is measured with ammeter. Potential difference is measured with a voltmeter. And the resistance is measured with an ohm meter. Guys, the resistor is measured with an ohm meter. Please don't forget this. So, any question before we move on to Ohm's Law? Any question before we move on to Ohm's Law? None. If we all understand, can we raise our hands so that I'm going to know that we'll move on to the next thing? Okay, if we all understand, let us indicate by raising our hands so that we'll move on to the next thing. Okay. It means an appreciable number of us understands. So let me know if you can still see my screen. Okay. We have Ohm's Law. I'm sure that basically all of us can define Ohm's Law. We learned Ohm's Law in junior secondary school, and we have learned Ohm's Law in SS1. And provided you do electricity in secondary school, you will continue to learn Ohm's Law. Okay, so Ohm's Law, you can define it the long way. When electric current passes through a metallic conductor, we should know that Ohm's Law holds majorly for metallic conductors. We have other conductors that are not metallic conductors, but that's advanced physics or advanced electricity. Provided that the wire is kept constant, the current passing through a metallic conductor when the wire is at constant temperature is directly proportional to the potential difference applied between its ends. So Ohm's law simply states that if you cannot remember all of this, like if you define Ohm's law the first way for your wire class, most likely if it's supposed to be 10 marks or 5 marks, you're going to get all of your 5 marks. But because we're students and because in exam or we might be shivering, we might not just remember that it's a metallic conductor. We should know that Ohm's law simply states that current is directly proportional to potential difference. If you define it this way, you get 60 or you get most likely 70% of your mark. So don't make metallic conductor make you lose marks. So just know that Ohm's law means when current is directly proportional to potential difference. In Ohm's law, we should know that Ohm's law only holds when we assume that all other physical parameters remain constant. Like we believe that the temperature is constant, the pressure is constant, there is no air resistance, the material is metallic. Ohm's law only holds after we have assumed that all of those things are constant. In case of any change, that the pressure is not constant, Ohm's law does not hold. You can be asked for limitations of Ohm's law. I'm sure that along the line we're going to learn that. But you should know that Ohm's law only holds when we assume that physical conditions remain constant. So mathematically, Ohm's law can be represented as V is equal to IR, or when I'm making I the subject of formula, I is equal to V over R. When I'm making R the subject of formula, R is equal to V over I. I hope you understand, guys. So limitations of Ohm's law. Limitations of Ohm's law simply means that when these conditions occur, Ohm's law does not hold. Ohm's law does not hold when temperature is not constant. If we have a rise and fall in temperature in a particular room, you cannot use Ohm's law to determine any of your parameter, either your voltage, your current, or your resistance, because it fluctuates. So as in a room that has a varying temperature, Ohm's law does not hold. When the conductor is under tension or is looped, for example, the wire you are using, when it's under temperature tension, maybe it's being drawn or it's being stretched beyond its limits, or the temperature is now being cold. I'm sure that we all know that when we are doing our basic physics practicals in school, we ensure that our wires are straightening up, like we straighten up our wires. So if you begin to bend your wire or you begin to loop your wire, you cannot use Ohm's law any longer. Then I'm sure that we all remember Faraday's law of electromagnetic inductor, then all of those things come in. But we are still going to be using Ohm's law. Your conductor must not be under tension and it must not be looped. Then Ohm's law does not hold for conductors such as radio waves, radio valves, transistors, semiconductors. Because for all of these conductors, they are either under tension or they are looped, or they are not metallic conductors. I hope you all understand what I've said. So I have questions for you on Ohm's law. Let us check out the questions we have on Ohm's law before we move on. So any question, guys? Any question before I give out the questions? Oh, I'm sorry, guys. I'm sorry. Is there anybody that cannot hear me clearly? Please let me know. Okay. If you cannot hear me clearly, let me know. Do I need to repeat any of the things I've said before? Okay, if I need to repeat any of the things I've said before, please kindly let me know. I have some questions for you. Wow, I can't. Ah, God, this is. Okay, let me see. Let me see what I can do. Okay, this is not clear enough, but it's a worksheet. I'm going to read it out to you, and I'm going to send it to you via WhatsApp. So please let us manage it. It was clearer when I downloaded it. I don't know what happened. But please let me see. I'm going to read out the first question to you, and we're going to solve together. A current of 3.7 amps is running through a circuit like the one above with a resistance of 1.5 ohms. What is the voltage? A current of 3.7 amps is running through a circuit like the one above with a resistance of 1.5 ohms. What is the voltage? I'm going to read it one more time, then we will solve. A current of 3.7 amps is running through a circuit like the one above with a resistance of 1.5 ohms. What is the voltage? So, what is voltage? Okay, I'm going to show it very soon. The question once again. The current is 3.7 amps and resistance is 1.5 ohms. So we're looking for the voltage. So let us solve. Students, dearest, can we solve? Okay, nice one. How did we go about it? How did we solve? What formula did we use? What formula? V is equal to IR. What else? What did we do? Okay, I want Hafsa Abdul Kabir, share your screen with us and show us the solution. Hope you can hear me clearly. With your screen, show us the solution of that question. We're waiting. Hafsa, we're waiting for you. Hafsa, can you share your screen? Can you use the whiteboard? Okay. Just use the whiteboard. Use the whiteboard. Hafsa. We're waiting for you. Use the whiteboard. Let us see. So the next question, so that you get prepared. Blue is going to be solving the next question for us. And I'm going to be using the whiteboard. Asa, can you use the whiteboard? Just let me know if you can use the whiteboard. Can you? Okay, let me unmute you. Okay. All right, just dictate this to us. All right. Okay, 1 minute, please. So have to unmute yourself, please, and let us see so that we can listen to you.
The formula I use.
Okay, we're listening. How did you achieve that? How did you solve the question?
I did V equals to IR.
Okay. So
Then
what's your
I is 3.7. R
okay?
is 1. Then
Okay.
apply the volts. Then the answer is 5.55 volts.
Okay, thank you. Wonderful. You have done well. Thank you. So the next question, I'm going to be reading out the next question. And Blue, hope you are ready to solve. Sorry, please. What do you want? The next question. If the current in the circuit is 10 amps and the resistor is 3 ohms, what is the voltage? If the current is 10 amps and the resistor is 3 ohms, what is the voltage? So show us your solution, please. I want to see it. Okay. I'm waiting. Blue, I'm waiting for your solution. Okay? Let me repeat the question. If the current is 10 amps and the resistance is 3 ohms, what is the voltage? Please let us start resistance in series today, guys. So I'm waiting on you guys to be fast. Okay? All right. I told somebody that he was supposed to solve and he isn't. Okay. So I'm just going to be dictating the last question for now. And I'm going to send questions to you guys. Your car battery is 12 volt DC source, direct current source. Typically, you might use a fuse that can handle a 5 ampere surge. What is the resistance the fuse? Okay, what resistance is that fuse protecting? I hope, can you all hear me at all? Your car is a 12 volt DC source. Your car battery is a 12 volt DC source. Typically, you might find a fuse that can handle a 5 ampere surge. What resistance is that fuse protecting? So guys, your car battery has a 12 volt DC source and uses a fuse of 5 ampere. What resistance is the fuse protecting? So we're looking for the resistance now. Solution, everybody, in 1 minute. 12 volts and 5 ampere surge. So what's the resistance? Okay. Nice one, guys. Nice one. I love the fact that you guys are participating, but if you have any question, please kindly let me know. So let us move on to resistors now. We're going to treat resistors in series today, and I'm going to send questions to you on resistors in series. And in our next class, we're going to be starting from resistors in parallel because it's almost 12. So resistors in series. When two or more resistors are arranged such that R1, R2, R3, R4, it can be more than that. It can be R1 to R10. It can be R1 to any number of resistors. And they are connected end to end. It means that they are connected on a straight line. The end of one resistor joins with the end of another resistor, such that current flows through each resistor when they are connected to a source, EMF. They are said to be connected in series. In series connection, they do not divide the current. The same number of currents that flows through A, flows through B, flows through C, flows through D, or any number of them. I'm sure that when we're doing this, resistors in series and parallel and capacitors in series and parallel, students tend to mix it up. Know that when resistors are connected in series, the current does not change. For example, if you want to, in a solar, in an inverter production, and we need 2 amperes of current, we got batteries and we want 2 ampere. Each of the battery has 1 ampere each. The current is 1 amps. If we want to connect it, we're going to connect it in parallel because we need the current to add up. But we need 1 ampere of battery. If we're connecting in parallel, it means we're connecting positive to positive, negative to negative. But if we're connecting in series, we're connecting positive to negative, negative to positive. So if we need 2 ampere of batteries, if we need 1 amp of battery, we're going to connect the battery in series. But if we need it to be 2 ampere, we're going to connect it in parallel because when we connect in parallel, the current adds up and the voltage remains the same. When we connect in series, the current remains the same and the voltage adds up. Please, if you don't understand this particular thing I've told you, I want you to tell me. Because we make mistakes of, is it when we connect in series that current add up? Is it when we connect in parallel? Students tend to make that mistake. But we should know that when we connect in series, the current remains the same and the voltage adds up. So it means in resistor 1, if it has voltage of 0.01 ohms, in resistor 2, it has voltage of 0.02 ohms, in resistor 3, it has voltage of 0.03 ohms, in resistor 4, it has voltage of the volts at I hope you cannot hear me, guys. Guys, I hope you can all hear me and I hope you can all see my screen. Okay, guys. So then for series arrangements, the resistor is added. R1 plus R2 plus R3. In our next class, we are going to be learning resistors in parallel. If you can hear me, please let me know. Okay, any question from everything we have done today? Okay, the last question. We were given, let me check the question again. For the last question, we were given voltage of 12 volts and current of 5 amperes. So we just did 12 divided by 5. So that's 2.4. So guys, any question? Your questions before we round up with the class. Your questions. Questions. No questions. So it means we can round up with the class. I'm going to send the slides to you, and I'm going to send the worksheet to you. So please read up the slides and answer all of the questions in the worksheets. I told you guys in our last class that you should submit the slides, that you should submit your assignments. None of you did. Okay. So I'm going to send the worksheets and the slides to you. Thanks for today's class. Hope you guys would have a wonderful weekend and just enjoy yourself.